So in 11.6, we're going to stay with our quadratic function. So we're still going to be graphing parabolas, but we're going to have to put them into our form that we used in 11.5. So from the last section, we know this form. Okay. Now, let's talk about a little bit more about what that form is. So the vertex for this parabola would be located at the point h comma k. Remember the last example we did in 11.5. We shifted the vertex. That's what exactly happens here. So my vertex is going to be h. It's always the opposite of what's in here. So that's why, because this is a minus, it's actually positive h comma k. Remember, what does the A do? Well, the A tells it shape. It makes it skinnier or wider. And then if the A is negative, it also reflects it either going, or well, it would have to reflect it going down if it was negative. Okay, so we know all of that from 11.5. The problem is this is not in this form. We need to do our best to get this into this form, ax minus h quantity squared plus k. Okay, so here we go. What I would do as I watch this is I wouldn't write it down the first time. I would just watch me do it, and then I would replay it and write it down. And I would probably do that for the first couple of examples here. So notice we need a perfect square here. Remember how we completed the square in the last chapter when we were solving equations, quadratic equations? We're going to have to complete the square here. So what I first want you to do is I want you to take and I want you to move the -5 over. I'm moving that -5 over because it's not part of my incomplete square. The first two terms here are my incomplete square that I need to complete. So I'm going to make this into a perfect square so I can factor it so it looks like x minus h squared. Okay, well, remember the steps for completing the square? You take half of the b, so I'm going to take half of -4, which is -2, and I'm going to square it, and -2 squared is 4. Now watch carefully what I do with it. I'm going to add 4 here to complete the square. But wait. You can't just randomly add 4. Now, when we were doing equations, what we did is when we added 4 to the right, we also added 4 to the left, but we don't want to change this f of x over here. So because we're working on only one side of the equation, since I added 4 here, I'm going to go to the end and I'm going to subtract 4. I counteract what I did. Because if you think about it, if I add 4 and then subtract 4, what have I really done? I've added 0. And that's your goal. You don't want to change the meaning. You just want to change what it looks like. So now if we clean this up, I'm going to factor this. So that's going to be x minus 2 quantity squared. And I complete these to get -9. Now my a in front is a 1. So you can see the vertex is going to be 2, -9. Now, it also asks me to find the intercepts. Now, remember, intercepts are where it crosses the x-axis and the y-axis. So I now have my vertex. If I go ahead and if I find the intercepts, if I want to find the x-intercepts, that means I plug 0 in for y, or in this case, I plug 0 in for f of x, and I solve. Well, how do I solve that? I have to factor. So I'm going to get x minus 5x plus 1. If I take each of these factors and set it equal to 0, I'm going to get 5, and I'm going to get -1. Those are my x-intercepts. Those are the two places where this graph is going to cross the x-axis. So let's go ahead. That gives us a really good picture of the graph, just with those points. So first of all, I'm going to have 2, -9. So 2, -9 right here. So that's my vertex. It crosses the x-axis at 1, 2, 3, 4, 5, and at -1. That's pretty good to be able to graph my parabola. All right, let's go down to the next example. Now, with this one again, I would suggest that you don't write it down the first time. Just watch as I do it, because this one's going to be a little bit different because of the -1 in front. And then you can replay it and write it down the second time. So again, we want to get this into f of x equals a x minus h quantity squared plus k. It's going to be very similar to our first example, but there's going to be a twist. So the first thing I want you to do, just like above, is I want to take these first two terms and I want to put the 8 over here. I want you to shift it over because that's not part of our completing the square process. This is the square that we need to complete. So here's the twist. Do you remember when we solved with completing the square? The coefficient of the x squared had to be a 1. It's not a 1 here, it's a -1. So here's the twist. You have to factor out that -1 as a common factor, but you only factor it out of the first two terms. You do not factor it out of the +8. We've moved that over. We're ignoring it for now. If I factor a -1 out of here, I'm going to get x squared plus 2x. Now I complete my square. What's half of 2? It's 1, and 1 squared is 1. So I'm going to add 1 right here to complete the square. Now here's the tricky part. When I added 1 here to complete the square, I didn't really add 1. I added -1 times 1. If I were to distribute that -1 through, this would become a -1. So when I added 1, I really added -1, which is -1 times 1. So how do I counteract at the end -1? I'm going to go ahead and I'm going to add 1. So you always do the opposite. If there's a negative number here, you're going to end up adding at the end. If there's a positive number here, you're going to end up subtracting at the end. So if we go ahead and if we clean this up, you can see I have that, which means my vertex is at, remember it's the opposite of this, -1, 9. And we can tell from here that it's going to turn down. So now it also says to find the intercept. So again, to find the x-intercepts, we take our equation and we plug 0 in for f of x. So 0 equals -x squared minus 2x plus 8. I'm going to divide everything through by -1 because I don't like that -x squared. It always confuses me when I'm factoring. So 0 is going to be equal to x squared plus 2x minus 8. Luckily, it factors into x plus 4, x minus 2, which means that my x-intercepts, if I were to take each of these and set them equal to 0, would be -4 and +2. So I now have my vertex and my x-intercepts. I have enough information, so I'm going to go over here and I'm going to make a graph. So I know it crosses the x-axis at -4 and at +2. And I know its vertex is at -1, 9. And you can see it's going to do oops, that's a bad graph. Sorry about that. It's going to do exactly what we thought it would do. So getting it into that form is very important for you to be able to do. So that's one way to graph a parabola from that form, is to actually put it in the other form, which we've just seen 2 examples for. There's another way. The other way is, if I have this form, I don't have to change it to the f of x equals a x minus h quantity squared plus k. I can leave it in this form. To find the vertex, to find the x part of my vertex, there's a formula, and it is negative b over 2a. Do you see that's right here? So this is another way to find the vertex. So to find the x part of my vertex, I do negative b over 2a. And of course, we know here that b is negative 4 and a is 1. Then to find the y part of my vertex, I find f of negative b over 2a. In other words, I take my x and I plug it back in, which is always how we find a y, is we take an x and plug it in. And that will help me find the vertex. So here we go. If I want to find the vertex of this function right here without putting it in that other form, it would be x is equal to, well, since b is negative 4, negative b is going to be positive 4 over 2 times 1, which is going to be 4 over 2, which is 2. So in my vertex, the x coordinate is 2. How do I find the y? I simply go back and I plug in 2. So if I plug in 2 or find f of 2, that's really what I'm doing. It's going to be 2 squared minus 4 times 2 minus 5. 2 squared is 4 minus 8 minus 5. 4 minus 8 is negative 4 minus 5 is negative 9. And that would be the y of my vertex. So now I have my vertex, and I found that without putting it in that other form. Now I can still find my x-intercepts by plugging 0 in for f of x. Even though it doesn't say that I have to graph, I'm going to. It's good practice. So if I go ahead and factor that, you can see that I'm going to get x minus 5, x plus 1. So, whoops, if I set them each equal to 0, I'm going to get 5. And I'm going to get negative 1. So if I want to do just a quick graph, when I say quick graph, I really mean a quick graph. So 2, negative 9 is down here. And then at negative 1, I have an intercept. And at 5, I have an intercept. And you can see, I believe we graphed this exact same one on the front page. That's why it's all looking familiar. There you go. Okay, so here we go. A story problem. Quadratics are always a good place for a story problem. An object is thrown upward from the top of a 100-foot cliff. Its height in feet above the ground, t seconds, is given by this function. We've used a function similar to this before. So again, if I wanted the height at 0 seconds, I would plug in 0 for t. If I wanted the height at 3 seconds, I'd plug in 3 for t. So that's how this function works. Find the maximum height of the object and the number of seconds it took for the object to reach its height. And it says, don't panic if you get answers that are fractions. So let's think about this for a minute. If I were to graph, and don't worry, I'm not going to graph it, but if I were to graph this parabola, do you see that it would open down? So basically, here's what's happening. Here's this object. Where is its maximum height? Well, isn't its maximum height right here? And isn't that the vertex? So do you see really what they're asking us to find? We have got to find by using the vertex. So let's go ahead and find the vertex. Well, To find the x part of the vertex, we're going to use negative b over 2a. So my b is 10, so negative b would be negative 10 over 2 times negative 16. So that would be negative 10 over negative 32. So if I simplify this by dividing both top and bottom by negative 5, nope, it can't be negative 5, by negative 2, I'm going to get 5 over 16. So that means that the x part of my vertex is 5/16. To find the y part of my vertex, I need to plug that back in. So this is going to be fun. So if I want to find f of 5/16, it's going to be negative 16 times 5/16 squared plus 10 times 5/16 plus 100. All right, even I don't want to do that by hand, so I'm going to grab my calculator, and I love doing fractions. So negative 16 times 5 divided by 16 squared plus 10 times 5 divided by 16 plus 100. So I just went and I plugged it into my calculator, and I get about 101, let's say 0.6. So that would be the y of my vertex. So we have two questions to answer here. The first one is, what is the maximum height? Well, do you see height we're talking about would be the y of the vertex. So the maximum height that that object reaches is 101.6 feet. So there's the answer to one question. It then asks us for the number of seconds it took to get there. Well, remember your t, which is the same thing as your x, if you look, stood for time. That's just simply going to be the x part of your vertex. So it took 5/16 of a second to get to that maximum height, which makes sense. That's not very long, is it? But don't forget, it started at 100 feet. And if its maximum point is just a little over 101 feet, it's not going to take very long to get there. So there are your notes for 11.6.